All right, we did a lot of work to get our value of 75 for the derivative of x cubed at x equals 5. What if we hadn't been able to do all that work? Either maybe it was a more complicated function or we just didn't know how. So what can we do to get an approximate value there that will give us a tangent line that's, or give us a local linear approximation to the x cubed function that's pretty good, but not as good as this capital L of x function? In the homework, there's a few problems that say approximate the equation of the tangent line to the graph of f, which is confusing because the tangent line itself is an approximation of the graph, and now we're trying to get an approximate tangent line. So what could we do if we didn't have this number 75 and had to estimate it? I'm going to give you a hint. You can look at the Desmos graph we did before, something like this. So thinking back to that graph, can you change something here to give us an approximate 75? So pause the video in 3, 2, 1. Okay, welcome back from pausing. So I'm going to define a new function. I'm going to call it s of x, and I'll say why it's capital S later. And we know the value of the function at 5, but I don't know its slope. M is a good number to use for slope. And then we'll say x minus 5. I'm going to put a times here. I don't really need it, but just to make it clear that m is multiplying x minus 5. So now I need to say what that slope is. Well, in the other sheet here, we were computing the slope by doing the slope between 2 points. So I can do something like that. So I can say f of 5 plus something. I could use delta x, but that's hard to type in Desmos, so I'm going to use h minus f of 5, and then divide by h. And now I'm going to make h a slider. And I'm going to turn this line into a dashed line, and let's color it orange. By the way, you can change the color of a line by clicking and holding for a long time on the style of it. So now if I change h, I'm using this point and a point out here. In fact, I can put a point at 5 plus h comma f of 5 plus h. So that's a lot like x sub 2 comma f of x sub 2. So I'm getting those 2 points, and the orange line goes directly between them because I engineered its slope to do that. And then if I grab this point and drag it like I did on the other one, I'm using smaller and smaller h values. Desmos is even adjusting the h value for me there. And here, and as I do that, the orange line becomes a better and better version of the black line. And in the textbook problems, it says to use h equals 0.1, so I can just type that. So here, I got an approximate slope for the best local linear approximation of 76. We know the real answer is 75, so I'm doing pretty well. And why am I calling this capital S? Well, it's more obvious back here. Is this orange line a tangent line? Well, no, it goes through the function in 2 places rather than just one, so it's not tangent. The technical name for it is the secant line. It's more common in geometry to use the word secant to mean a line that goes through a curve at 2 places. So that's what those problems are getting at in the homework, and that's how the tangent line or the best local linear approximation relates to the stuff we were doing before. We could have drawn a line through those 2 points. Let's readjust this to be 5.1 like the book said it should be for the other homework problems.